Hello everyone, today I am here with a new video on quartiles, which is a topic from statistics and it is important from JEE main point of view. Let's begin. Before I talk about quartile, let me talk a little about percent or percentile. Okay. When I say this word percent or percentile, immediately in our mind comes 100. What are we thinking? Something is divided into 100 equal parts. Okay, so similarly, when I will be talking about quartiles, I can say something is divided into 4 equal parts. Okay, suppose I have a straight line, I want to divide it into 4 equal parts. I will cut it from 3 places. Let's say this is q1, this is q2, this is q3. This is what we mean by quartiles actually. q1, q2, q3 are 3 quartiles. This is not exactly what I'm meaning, but this is a good analogy to understand, to get a vibe of what a quartile is. Okay, and in JEE main we are basically dealing with the discrete data, so I'll be taking this topic in view of discrete data only. Fine. Okay, so I will be defining what is q1, q2, q3, but before that let me introduce another term, which is quartile deviation. Okay, this is also denoted as QD. So in words I can say this is semi interquartile range. Okay, so I have 3 quartiles, q1, q2, q3. How to calculate q1, q2 and q3, I'll be dealing it later. Okay, but first let's define qd. So qd is q3 minus q1 upon 2. Okay, interquartile range, that is the range is q3 minus q1, and semi means half. Okay, so qd is q3 minus q1 upon 2. What is q2? q2 is also known as median. Okay, q2 is our median. Fine, q2 has another name, median. One more term, what is coefficient of quartile deviation? So this is q3 minus q1 upon q3 plus q1 into 100. Okay, so this is the coefficient of quartile deviation. Fine. Okay, so now let us take an example to see what is q1 and q3. I will not be talking about q2 because q2 is same as median. q2 has another name, median, and I suppose you already know how to calculate the median of discrete data. Okay, so let's begin. Suppose I have been provided with marks of students, which is as follows: 56, 48, 65, 35, 42, 75, 82, 60, 55 and 50. Okay, so before we begin to calculate the quartiles, the first thing we are required to do is we have to arrange the data in ascending order. Okay, so let's do this first. First one is 35, second is 42, third one is 48, fourth is 50, fifth one is 55, then 56, then 60, then 65, then 75 and then 82. Okay, done. We have arranged the data in increasing order. Now how to find? Okay, now how many terms are there? Total there are 10 terms. Fine. So to calculate q1 we write q1 is equals to n plus 1 upon 4. Okay, why 4? We are dividing the whole data into 4 equal parts. That's why q1 is n plus 1 upon 4. Okay, actually this is n plus 1 by 4th term. Okay, fine, let's calculate q1. This is 10 plus 1 upon 4. Okay, so this is 11 upon 4, which is 2.75th term. Okay, So there is nothing as such 2.75th term. Fine. So what we do is we write it as 2 plus 0.75 of actually second, not 2, second, third minus second, okay, term. Now we are good to go. The second term is, let's see what's the second term in the arranged data, which is 42. Okay, so this is 42 plus 0.75, third minus second, third is 48 and second is 42. So this becomes 42 plus 0.75 of 6. Okay, so this is 42 plus 4.5, which is 46.5. Fine. Okay, so Q1 is 46.5. Now let's calculate Q3. Q3 is equal to 3 times of n plus 1 upon 4. Now please don't make the mistake here, as Q3 is not equal to 3 times of Q1. Why this may come into mind? Because I said Q1 is equal to n plus 1 upon 4 and Q3 is equal to 3 times of n plus 1 upon 4. So we may think that Q3 is equal to 3 times of Q1, which is totally wrong. This is wrong. Why wrong? Because this is not the value, this is the n plus 1 by 4th term actually, and this will be also the term. So please don't make the mistake to do this. Okay, fine. So let's calculate Q3. So Q3 is 3, again 11 upon 4, 3 into 2.75, and this comes out to be 8.25. Okay, actually 8.25th term. So what I can write, this is 8th plus 0.25 of 9th minus 8th. Fine. What is 8th term? The 8th term is, okay, this is 65 and 9th is 75. Fine. So this is 65 plus 0.25, 75 minus 65, which is equal to 65 plus 2.5. This is 67.5. Fine. Now let's calculate the quartile deviation. So quartile deviation is Q3 minus Q1 upon 2, which is 67.5 minus 46.5 upon 2, which is 21 by 2, which is 10.5. So our quartile deviation for the given data is 10.5. Fine. Let's calculate the coefficient of quartile deviation. The formula was Q3 minus Q1 upon Q3 plus Q1. So Q3 minus Q1 is 21 and Q3 plus Q1 will be 114. Calculate it yourself, multiplied by 100, and this comes out to be, I am writing it directly, 18.42. Fine. Okay, let's take another question. The quartiles for a given data is actually R. The quartiles for a given data are 20, 30 and 40. Find QD and coefficient of QD. Okay, so it is written Q1 is equal to 20, Q2 is equal to 30, Q3 is 40. QD is Q3 minus Q1 upon 2, which is 40 minus 20 upon 2, which comes out to be 10, and coefficient of quartile deviation is Q3 minus Q1 upon Q3 plus Q1. So this comes out to be 40 minus 20 upon 40 plus 20, which is 20 upon 60. That is 1 upon 3, which is 0.33 multiplied by, okay, this was multiplied by 100, multiplied by 100, multiplied by 100, 100 into 100, and this is 33.33%. Fine.